Hello everyone, myself Dr. Pradeepa SM, working as an assistant professor in Department of Chemistry. See, in this video, I am going to discuss about solar energy. Right? So, what is the source for the solar energy? Right? Actually, the radiations which are coming from the sun, right, constitute solar energy. Right? This solar energy is inexhaustible, it is renewable, it is freely available, and it is a local resource for all the peoples who are living on the Earth's planet Earth. Right? So this solar energy is very much essential for each and every one. Right? So according to one approximation, if few hours of solar energy or for solar sun radiations which are falling on the Earth, if properly converted and utilized, it can fulfill the energy requirement for almost all the human beings for one full year. Right? So such a huge amount of energy is there in the solar radiations. So the radiations which are coming from the sun constitutes solar energy. Right? So I repeat, so it is inexhaustible, it is renewable, it is environmentally friendly, and it is freely available. Right? So this is the importance of the solar energy. So if you look at the electromagnetic spectrum, the solar radiations, right, falls in the range of 100 to 1000 nanometer. The solar radiation in the range from 100 to 1400 nanometer are falling on the Earth's surface. Right? So out of this, see this 100 to 400 nanometer range which is coming under UV region. It is falling under UV region. Right? It consisting of UVA and UVB rays. Sometimes UVC rays also. Right? So these ultraviolet radiations, they are dangerous to all the living organisms which are present on the Earth's surface. Right? So that's why these radiations are absorbed by ozone layer which is present in the stratosphere, right, of our Earth's atmosphere. So that's why they will not come and fall on the Earth's surface. So unfortunately we are damaging ozone layer, right, by excess use of fossil fuels and chlorofluorocarbons and all. So that has to be reduced, otherwise these UV radiations will fall on the Earth's surface and it is a danger for each and every human being. Right? People will end up with skin diseases, so many disorders will occur. Right? So that is one thing. And the next, the remaining 45%, of total heat and light radiations or total light and heat radiations are falling on the Earth's surface. Right? They will fall under the range from 400 to 1400 nanometer. Right? Out of this 400 to 1400 nanometer, from 400 to 800 nanometer, they are called as visible region. Right? They are called as visible region, that is VIBGYOR. Right? It consists of light radiations. You can call it as light radiations. And the remaining radiations which are falling under 800 to 1400 nanometer, they are called as infrared radiations. Right? Or IR region, they are falling in this region, they are commonly called as heat radiations. They are commonly called as heat radiations. So this heat and light radiations are falling on the Earth's surface and they are available to convert it into useful work. Right? So we can utilize this and we can convert this into useful work. So this is about the introduction about the solar energy. Right? So if you come to the solar energy utilization, so how one can utilize the solar energy which is coming from sun radiations. Right? So there are two methods are there for utilizing the solar energy. One is, so there are so many n number of different technologies are there which are harvesting solar sunlight and they are converting into useful forms. Right? So out of that they are categorized into two ways. One is direct solar power utilization. Right? One way is direct solar power utilization, direct solar power utilization, and the other one is indirect solar power utilization. Indirect solar power utilization, right? So if you can see what are these direct solar power utilization, if you come to that, the example for this, so in case of direct solar power utilization, it involves only one step transformation into usable form. It involves only one step transformation into usable form, then they are called as direct solar power utilization. If you can give an example, it is just like solar cells. That means sunlight hits the panel of the solar cell and immediately it will convert it to electrical energy. The other example is solar water heaters, right? Same, sunlight hits the black body surface and the corresponding heat will be transferred to water will get heated. So that is also a solar power utilization. It involves only one step transformation. And similarly, solar spacecraft or solar sunlight strikes a solar sail, right, on the spacecraft, and the motion of the spacecraft is going to take place. So that is the example for direct solar power utilization. And coming to indirect solar power utilization, it involves more than one step transformation into usable form, right? So they are called as indirect solar power utilization. And if you want to give an example for this, you can give almost all the energy resources, because in one way or the other way they are interrelated to the Earth's atmosphere, that is solar radiations. So you can give vegetation. So vegetation uses photosynthesis, right? Sunlight is very much essential for photosynthesis to occur. Using this sunlight, photosynthesis will take place, plant will grow, and later we will cut the same plant and we will utilize it for heat energy, right? That is, it is more than one step transformation into usable form. So likewise, you can give an example for that hydroelectric power plants and wind turbines. They are all in one way or the other way they have the interaction with this Earth's atmosphere, that is sun radiations. So indirectly you can give that also because of the interaction with solar radiations. And similarly, ocean thermal energy, right, in one way or the other way it is related to that. And at last you can categorize these fossil fuels. They are also because of these solar radiations only. So actually they are whatever the energy which is obtained from crude petroleum, so several years ago, so these marine plants and animals, they have utilized solar energy and then get because of the time delay they are getting fossilized. Now we are extracting them as fossil fuels, right? So likewise, indirect solar power utilization is there. Okay, in this way we can utilize. So this is one way of classifying, saying how solar energy can be utilized. In the other way, solar energy can be utilized and can be named as, so one is one is thermal conversion. This is one way. The other one is thermal conversion. The other one is thermal conversion, and other one is photo conversion. Right? So we can classify like this also. We can, the utilization of solar power can be classified in this way also. Thermal conversion means, so utilizing the solar radiations to store the heat energy. Actually in several colder countries, right, in foreign countries, people are, they are storing the solar radiation in the rock pebbles, right, and through a piping system they blow air and they will utilize this heat energy which is coming from the sun to heat the room during night times, right? So that is called as thermal conversion, right? That is called as thermal conversion. For this you can give solar water heater also an example for this thermal conversion, like using sunlight or solar radiation you are going to heat water, right? That is thermal heat, right? So coming to photo conversion, here photo conversion, the very best example is solar cells or photovoltaic cells. That means sunlight hits the solar cells and the sunlight is directly converted into electrical energy. So it is just like one step transformation or solar sail. When a solar radiation hits on the spacecraft, it will be converted into the electrical energy. So they are called as photo conversion, right? Photo conversion. The very best example for photo conversion are the photovoltaic cells. Just like that in photovoltaic cells. Just like that in photovoltaic cells. or they are also called as solar cells. They are also called as solar cells, right? See, solar cells. See, before going to understand what are these photovoltaic cells or solar cells, actually the solar cells or photovoltaic cells are the semiconductor devices which convert, if you want to define this, these are the semiconductor devices which converts sunlight into direct current electricity, which convert sunlight into direct current electricity. So that's why here these are the semiconductor devices. You need to have a little bit idea about what are semiconductors in order to understand these sort of photovoltaic cells or solar cells properly. So for that reason, dear student, listen, I will give a brief introduction or explanation about semiconductors, right? So you all know that what are semiconductors. So semiconductors are the substances whose conductivity band lies in those between of conductors and insulators, right? Conductors and insulators. So in semiconductors there are two types. One is intrinsic semiconductor and the other one is extrinsic semiconductor. Intrinsic semiconductors are called as pure semiconductor, extrinsic semiconductors are impure semiconductors. So in case of intrinsic semiconductor, the conductivity of the semiconductor can be increased just by heating, right? If you increase the heat, just by increasing temperature, bond will break and electron will jump from valence band to the conduction band. So how many number of electrons which are jump from valence band to conduction band, that many number of holes are created in the valence band. So if the conductivity can be increased by increasing the temperature, then they are called as intrinsic semiconductors. They are pure form of semiconductors. The other type of semiconductors are extrinsic semiconductors, right? In case of extrinsic semiconductor, the conductivity can be increased by doing doping, process called as doping. So doping is a process of adding an impurity, either a pentavalent impurity or a trivalent impurity into a semiconductor lattice, right? So if you are doping a pentavalent impurity into a semiconductor lattice, then it is called as n-type doping, and if you are doping a trivalent impurity into a semiconductor, then it is called as p-type doping, and the corresponding semiconductors are called as n-type semiconductors and p-type semiconductors, right? So in case of n-type semiconductors, electrons are the majority charge carriers, and in case of p-type semiconductors, holes are the majority charge carriers, right? So remember, so if you want to determine, if you want to prepare, actually in some of the electronic devices, right, in electronic fields and just like in solar cells, they require a p-n junction diodes, right? A p-n junction diodes, that means combination of p-type as well as n-type semiconductors, right? Combination of p-type and n-type semiconductor that can be prepared by using various methods. One simple method is by doping and one type of impurity into a semiconductor that already consisting of another type of impurity. In that way you can prepare p-n junction diodes, right? p-n junction diodes, and in some of the electronic applications we want p-n junction diodes, right? So this is the information. Why I told this, because in photovoltaic cells are the semiconductor devices. I hope you understand. So with this basic information, now let us go to understand the construction, working and applications of these photovoltaic cells. So now we can take up these photovoltaic cells. Photovoltaic cells. So they are, in short, they are called as PV cells, okay, or solar cells. Remember. So I already told the definition how one can define the photovoltaic cells or solar cells are the semiconductor devices which convert sunlight into direct current electricity. So that is the definition. So here we can discuss about the construction, working, applications, that is advantages and disadvantages of these photovoltaic cells or solar cells, right? So if you come to the construction, as I already told, these photovoltaic cells are made out of semiconductors which have the capacity to absorb light, right? Which have the capacity to absorb light. A typical silicon photovoltaic cell consisting of a thin wafer consisting of an ultra thin layer of phosphorus doped silicon on top of the boron doped silicon so that a p-n junction will be formed, right? So phosphorus means pentavalent pentavalent dopant, that is n-type silicon on top of the p-type silicon is consisting that thing, hence a p-n junction is formed. So once a p-n junction is formed, it will separates carriers, it will separate electrons and holes and will move the charge carriers preferentially in a specified direction, as a result of which photoelectric current will be generated, right? So if you come to these photovoltaic cells, these solar cells or photovoltaic cells, they consisting of p-n junction that is made out of silicon, right? So it has two electrical contacts, one of which is in the form of a metallic grid and the other is a layer of a metal, that is a noble metal such as silver, right? So in between the metallic grid lines, sunlight will fall on the semiconductor, and this gap, that metallic grid lines, is coated with an anti-reflective layer, that is silicon nitride will be coated in the anti-reflective layer so that it will increase the amount of light transmitted through the semiconductor So if you can write the diagram of for construction, so you can write like this. So what I told, it is made out of consisting of a p-n junction made out of silicon, so that's why you can write a diagram like this. Okay, so it has two electrical contacts, one of which is in the form of metallic grid, right? One of which is in the form of a metallic grid, the other is a layer of noble metal on the back of the panel, right? This is their metallic grids like this into right. At last this. Okay, so now it consisting of a thin wafer consisting of an ultra thin layer of phosphorus doped silicon. That means n-type region will be on the top of this p-n junction diode. So n-type region, and below this is p-type region. So I already told, in n-type region electrons are the majority charge carriers, in p-type region holes are the majority charge carriers. So these are the metallic grids, right? These are the metallic grids. So it acts as one of the electrical contact. Right, so if you can denote this, these are metallic grids. Okay, these are metallic grids, and this is an metal contact such. So metal contact, right? It is a metal contact such as noble metal such as silver will be taken for metallic contact, right? This will be usually on the back of the panel. It is there. So like this you can write. So this, in the gap between the grid lines, is coated with an anti-reflective layer, that is silicon nitride. Okay, an anti-reflective layer such as silicon nitride. So because silicon is having very refractive index, so that's why in order to reduce that, we are going to put an anti-reflective layer in between the grid lines. Right, so this is an anti-reflective layer. See, an anti-reflective layer such as silicon nitride is coated. So now if sunlight falls on this semiconductor between the grid lines, what this anti-reflective layer will do, it will increase the amount of light falling on the semiconductor. It will increase, it will enhance, right? So if sunlight falls like this, right, between the grid lines, so this is an H nu, right? It is H nu, sunlight falling normal to the plane of the solar cell. Immediately what it will form is, it is going to form electron hole pairs, like plus and electron, okay, electron hole pair like this. It is going to form an electron hole pair like this. So these are called as electron hole pairs. Electron hole pair, right? So now, so you have to connect both these two ends using a conductor. So one of the contact is this metallic grid, so that's why we'll take this, okay, this acts as one of the metallic contact. So like this, and you have to give it to an application, right? Application, right? So the other contact is this noble metal such as silver on the back of the cell, right? So the electrons will move from p-type region, so electrons will move like this, and this is the thing, right? This is the construction of this photovoltaic cells. See how you need to explain. It is consisting of a PN junction made out of silicon, right? So it has two electrical contacts, one of which is in the form of metallic grid, the other is a layer of metal such as noble metal such as silver on the back of the panel. So sunlight falls between the grid lines, right, on the semiconductor. Anti-reflective coating or layer will be coated in between these grid lines, that is silicon nitride. This will increases the amount of light transmitted through the semiconductors. So this is all about construction, right? So coming to working, right, this is the construction. Okay, so coming to working, so here how these solar cells are going to work is, see, usually sunlight is an electromagnetic radiation, right? It consisting of particles called photons, right? It consisting of discrete pockets of energy that is called as quanta or photons. So each photon is associated with certain definite amount of energy. It is in the integer multiple of h nu, right? It is in the integer multiple of h nu, and it will be given by Planck's quantum equation. So that will be given by Planck's quantum equation. So that expression is E is equal to h nu, and we know that it is hc by lambda, where nu is c by lambda. So this is called as Planck's quantum equation, right? So h is Planck's constant, c is the velocity of light, lambda is wavelength of radiation, right? So each sunlight or solar radiation consists of energy as per Planck's quantum equation, right? So if you see when the electromagnetic radiation or when solar radiation falls, so solar radiation, so sunlight falls normal, okay, falls normal to the plane of the solar cell, right? So when sunlight falls or solar radiation falls normal to the plane of the solar semiconductors or solar cells, so the photons, only the photons which possesses energy which is sufficient to overcome the barrier potential, that is Eg, right, will be absorbed, and immediately an electron hole pair will be formed like this, right? Only the photons which possesses energy which is sufficient to overcome the barrier potential will be absorbed, and electron hole pair will be formed, right? And this is shown in this figure, right? So now if you so now if you drift and collect, right, if you drift and collect the electrons, so now what happens, the electrons are drifted to and collected at the n-type end, and holes are drifted to and collected at the p-type end, and when these two ends are connected externally using a conductor, so there occurs a flow of current between the two ends, and hence photoelectric current is generated. So in this way we are going to convert solar radiations into direct current electricity, right? So here when sunlight or solar radiation falls normal to the plane of the solar cell, only those photons which possesses energy which is sufficient to overcome the barrier potential will be absorbed, electron hole pair will be formed, electrons are drifted to and collected at the n-type end, holes are drifted to and collected at the p-type end, and when these two ends are connected externally using a conductor, then there is a flow of current takes place in an external circuit, and thus that is called as photoelectric current. So in this way you can understand construction and working of photovoltaic cells. So this is just an example for a single solar cell, right? Single solar cell. This single solar cell is able to produce, this single solar cell, if you can take this as a single solar cell, it can be written like this. It can able to produce only 0.5 volts of electricity, right? It is one single solar cell, right? So that's why it cannot be used for electrical generation. If you want to go generate electric current, you have to connect at least 36 such cells, either are to be connected either in series or parallel, and that is going to form a module, right? And that's a combination, that setup is called as a module, right? So that module act as a basic basic building block for the generation of electric current using solar radiation, right? Actually it is supposed to generate 18 volts of electricity, but in reality it is going to generate only around 12 to 14 volts. The remaining electricity will be lost due to heat radiations, right? Because the cell gets heated in the sun. So if more energy is required, right? So this is called as a cell. So this is called as a cell, and if 36 such cells are to be connected either in series or parallel, you are going to get a module, right? So this module will be the basic building block for the generation of electric current. So if more energy is required, you have to connect 4 or 5 such modules either in series or parallel by what is called as struts in the panels, and they are called as panels. So usually we are going to see this type of panels in and around our environment. People are using these panels in order to generate electric current from solar radiation. So if you want to get more electricity, or if you want to generate a building block for the generation of electric current, then you have to go further, right? If you want more electricity, if you want to generate more electric current from solar radiation, then you have to go for one more type of cells. They are called as arrays. They are called as arrays. These arrays, right? These arrays are the combination of 2 or 3 or 4 or 3 or 4 such panels which are connected either in series or parallel, as a result of which we are going to get very high electricity using these arrays, right? So this is the information. So this is an extra information just to know the things, because this whatever we have written, it is an example for a single cell, and then module, and then panel, and then arrays. Usually a panel requires around 1.85 to 3.25 square meter area will be there, so that's why it is suitable for domestic application, residential purpose, right? So with this now we can go for understanding what are the advantages. So if you can list out the advantages, so here only I will write, if you list out the advantages of these solar cells or photovoltaic cells, see, as I already informed, this solar energy is inexhaustible, renewable, freely available, environmentally friendly. So that's why these solar cells or photovoltaic cells make use of renewable source of energy, produce no pollution, and therefore they are environmentally friendly. This is the first advantage, right? This is the first advantage. Then there is no need of recharging of these solar cells. There is the second advantage, and if you go for third advantage, there will be no movable parts in the solar cells. So that's why cells will not get suffer from wearing or tearing, right? There is no question of wearing or tearing, right? And there will be a quick installation can be done, and these cells are going to work under ambient conditions, okay, under normal conditions. So that's why, so they are more friendly. They will not undergo corrosion because there will be no movable parts. So these are all the advantages of these solar cells. See, coming to the disadvantages, right? Coming to the disadvantages, so these disadvantages are, so the first disadvantage, like you can list out 3, 4, 5. So the disadvantage, see, the first and primary most disadvantage is it works only in presence of sunlight, right? That is, during daytime only it is able to convert solar energy into electrical energy, because during night time there will be no solar radiations, right? So remember, it works only in presence of sunlight. And second disadvantage is the efficiency of these solar cells depends upon seasonal variations, right? It depends upon seasonal variations like climate, right, and latitude, etc., right? All the times we are not going to get a same efficiency. During rainy season it is less, during winter in summer it is high, during winter it is moderate, like that. It depends upon the seasonal variations, right? And the conversion, the third disadvantage is the conversion efficiency per square meter of panel surface is only around, actually it is only around 14 to 19%, right? It is very less compared to other sources, right? A 30% efficient gallium arsenide or indium selenide multi-junction cells are also there, but they are expensive, right? They are expensive. So that is another thing. So another disadvantage is space. So space is a constraint. So usually it requires a considerable amount of space in order to generate unit power. So that's why the space required to generate unit power is relatively more, because you know that in metropolitan cities like Bangalore, Kolkata, Delhi, people are taking only 30-40 sites, and they have constructed even the roof, terrace, everything will be useful. If it consumes that much space, it is a disadvantage. And then if you come to dust, so dust often accumulates on the solar panels, that will reduce its efficiency, and at last high installation cost, you can give that example. And the last disadvantage is these photovoltaic cells produce only DC current, and if you want to store it, it must be converted into any AC current, right? So these are the disadvantages of these solar cells, right? So as even though there are some disadvantages, as it is a renewable source of energy, as it is freely available, as it is inexhaustive, as it is environmentally friendly, we have to motivate people to go and generate more and more solar radiations, or solar energy, right? So this is all about the explanation.